It's the year 2100. You're standing on the surface of the moon looking up at the Earth, a distant blue marble in the sky. The air is thin but breathable within your helmet, and behind you a sprawling lunar city hums with life. People walk along streets built beneath giant domes, and farms are thriving inside greenhouses that stretch for miles. You can see spacecraft arriving and departing, connecting the moon to Mars and even larger space stations orbiting above. Sounds like science fiction, right? But this could be humanity's reality in just a few decades. In fact, the idea of space settlements, places where humans live, work, and thrive off-planet, is no longer just a dream. It's becoming an achievable goal. From the first human landing on the moon in 1969 to the current plans for sending people to Mars, space exploration has evolved rapidly. But what does it really take to build a permanent settlement in space? How do we go from space missions that last a few days or months to establishing entire colonies where people can live for years, or even generations? Well, that's what we're going to explore today. The frontier of space settlements in the year 2100. And let me tell you, it's going to be a wild ride because by the end of this journey, we'll have a clear vision of what life could be like for humanity living in space. Picture bustling colonies on the moon, thriving cities on Mars, floating habitats in orbit, and maybe even settlements on distant moons like Europa or Titan. It's all possible, and the technology and innovations to make it happen are already in the works. Now, why are we even talking about space settlements? Why leave Earth? Well, let's face it, our planet isn't going to be around forever. Sure, it'll be a long time before we need to worry about Earth's ultimate fate, but think about the challenges we're facing right now: overpopulation, climate change, resource depletion, and the increasing risks of global disasters. It's no surprise that people have started looking beyond our planet for the next step in human survival. And no, we're not talking about escaping Earth because it's some kind of getaway. It's about ensuring the long-term survival of humanity. We need to diversify our existence beyond a single planet. The idea of expanding humanity into space isn't a new one. Science fiction has imagined it for centuries. Look at 2001, A Space Odyssey, or books like the Mars Trilogy by Kim Stanley Robinson. These stories painted a picture of humanity living on other planets, exploring the cosmos, and finding new ways to thrive beyond the confines of Earth. But now, these stories are starting to become a reality, thanks to a combination of advances in technology, science, and human ambition. Let's talk about where we might begin. The moon is, of course, the obvious starting point. It's relatively close, just about 240,000 miles away, so it's much easier to get to than Mars or other planets. The moon could serve as a launching pad for deeper space exploration, a place to test the technology needed for space settlements, and even a source of resources like water ice, which could be used to support life and fuel space travel. Imagine in the near future building a base on the moon with the goal of turning it into a thriving community. It's not as far off as you think. Then there's Mars, the red planet that has captured our imagination for decades. Mars has long been the dream destination for human colonization. With its day length similar to Earth's and evidence of water ice beneath its surface, it's considered the most viable planet for humans to settle on. But getting to Mars and living there is going to require some serious innovation. The challenges are enormous, the atmosphere is thin, the surface temperature is frigid, and radiation from the sun is a major concern. But scientists are already working on technologies to overcome these hurdles, from building habitats that can protect us from radiation, to creating systems that can recycle water and air. Mars might just be the first true space colony we build, and that's just the beginning. As we look beyond the moon and Mars, the idea of space settlements could expand to other moons in the solar system. Moons like Europa, one of Jupiter's icy moons, or Titan, Saturn's largest moon, have environments that could one day be harnessed for human habitation. Of course, these places are even farther away, and they present their own set of challenges. But the idea of establishing colonies on these moons might not be as far-fetched as it seems. In the future, space travel could become routine, making these distant worlds accessible. But let's pause for a second and think about the big picture. Why do we want to settle space at all? Well, first of all, it's about survival. Humanity is facing challenges on Earth that might threaten our future, from natural disasters to potential asteroid impacts to global conflicts. If we can't diversify our existence by spreading out into space, then we're essentially putting all our eggs in one basket. Space settlements would act as insurance for humanity, giving us a chance to survive if Earth faces a catastrophe. It's also about exploration and opportunity. The frontier of space is as wide open as the American West was in the 1800s, filled with possibilities. New resources, new scientific discoveries, and the opportunity to build entire new societies are just some of the rewards that await. There's a sense of adventure and curiosity that has driven human progress for centuries, and space settlements would be the next chapter in that journey. So, how do we get there? What's the path forward for space settlements? In the coming parts of this documentary, we'll take a look at the technology, the science, and the challenges involved in making space settlements a reality. From the ships that will carry us to new worlds, to the sustainable habitats that will keep us alive, to the social and political systems that will govern space colonies, we'll cover it all. By the year 2100, the dream of living in space might just be our new reality, so buckle up. It's going to be an incredible ride. Alright, so now we're starting to get excited about the idea of space settlements, right? But how do we actually make this happen? What kind of technology is going to get us from dreaming about colonies on Mars to actually living on them? Well, let's dive into the tech side of things. The tools, the innovation, and the crazy breakthroughs that will shape our journey into the stars. First up, let's talk about getting to space. We all know rockets are the key to launching anything beyond Earth's atmosphere, but the rockets we have today are just the beginning. Think about it. Right now we're using huge single-use rockets like SpaceX's Falcon 9 or NASA's SLS to get cargo and astronauts to space. But here's the problem. Rockets like these are expensive and they're not reusable enough to make frequent space travel feasible. The future? It's all about reusable rockets. And we're getting closer to that reality every day. Companies like SpaceX, Blue Origin, and even smaller players in the private sector are working on fully reusable rockets. Imagine a world where rockets take off, complete their mission, and land back on Earth, just like an airplane. SpaceX's Starship, for example, is designed to be fully reusable, and that's going to drastically cut the cost of space travel. In fact, reusable rockets are considered the key to opening up space for everyone, from scientific missions to tourists to entire settlements on the Moon or Mars. And we're not just talking about 1 or 2 launches a year, we're talking about regular, sustainable flights that could transport cargo, supplies, and even people to other planets with ease. But of course, getting to space is only part of the challenge. Once we're out there, we need to have a way to survive. Space is not a forgiving place. There's no breathable air, no water, no food. We'll need technology to create self-sustaining habitats that can support human life for long periods of time. And that's where things get really interesting. One of the first technologies that's going to make space settlements possible is life support systems. Right now, we rely on massive, complex systems to keep astronauts alive on the International Space Station. These systems filter the air, recycle water, and provide food, but these are still pretty basic compared to what we'll need on a larger scale. For long-term colonies, we need to create environments that can handle everything from providing oxygen to growing crops to dealing with waste. Think of it like this: in space, there's no away to throw things. Everything has to be recycled and reused. Water that's used in the habitat needs to be purified and filtered back into the system. Air has to be constantly replenished, and waste needs to be processed or turned into something useful. It's not easy, but it's essential. In the future, these systems will be super efficient, relying on the latest technologies to keep the colony running smoothly, whether that means water purification systems, hydroponic farming, or advanced air filtration. Next up, let's talk about the food we'll be eating on these colonies. If we're serious about long-term space living, we can't keep shipping food from Earth. First off, it's too expensive, and second, the amount of food required to feed an entire colony would be insane. So we'll need to grow our own food, on Mars, the Moon, or even on orbiting space stations. Hydroponics and aeroponics are the key to growing food in space. These are soil-free farming methods that rely on water and nutrients to grow crops. In fact, NASA has already had great success growing plants in space using these methods on the ISS. By 2100, it's not just going to be a few leafy greens here and there. We're talking entire farms producing everything from fruits and vegetables to protein-rich foods like beans, and potentially even meat alternatives. This means that future space settlers could be enjoying fresh meals made from ingredients they grew themselves, but food isn't the only thing that's going to be a challenge. We also have to think about how to protect settlers from radiation. The Earth's atmosphere shields us from harmful radiation from the sun and cosmic rays, but on the Moon or Mars, that protection doesn't exist. So, how do we keep settlers safe? Enter the technology of radiation shielding. On the Moon or Mars, we'll need to build habitats that protect people from radiation exposure. Scientists are looking into all sorts of creative solutions, using the planet's own resources like Martian soil to build thick walls around habitats, or even using water as a shield. Water absorbs radiation really well, so creating habitats with water walls or even ice could provide the necessary protection. It's a challenge, but we've got smart minds working on it. And then there's the bigger question: how do we make life on Mars or the Moon as Earth-like as possible? One way is through terraforming, transforming a planet's environment to make it more hospitable for humans. While this is still very much in the theoretical stages, there are some ideas on the table. For Mars, for example, scientists are considering ways to thicken its atmosphere, warm the planet up, and introduce a more Earth-like cycle of day and night. While full terraforming might be centuries away, we'll likely start with more practical solutions, like creating enclosed, controlled environments where humans can live, work, and grow food safely. And while we're dreaming about all this cool tech, let's not forget about the energy needed to power these settlements. On Earth, we rely on solar, wind, and fossil fuels to generate energy. But on Mars or the Moon, solar energy will be the most viable option, thanks to the abundance of sunlight. That means building huge solar farms to generate electricity. In the longer term, we might even develop nuclear fusion, an energy source that could power entire cities on distant planets. So, when we're talking about space settlements, we're really talking about a whole suite of cutting-edge technologies coming together, from rockets that can get us there to habitats that can keep us alive, to farms that will grow our food, and energy systems that power everything. It's a massive undertaking, but each piece of the puzzle is falling into place. And every day we get a little closer to making space settlements a reality. Now that we've covered the tech, the systems, and the basic need for space settlements, let's zero in on Mars, our best bet for humanity's first true off-Earth colony. For decades, Mars has been the dream destination for human exploration. But why? What makes Mars the most viable candidate for becoming the first real space colony? Well, it's not just about the fact that it's right next door in cosmic terms, there's a lot more to it. First off, Mars is the most Earth-like planet in the solar system. It has a 24-hour day, which is pretty similar to ours. The gravity on Mars is about 38% of Earth's, so it's not a huge leap for the human body. It's definitely lower gravity, but it's not like the zero-gravity environment you experience on the International Space Station. Plus, Mars has seasons, just like Earth does. There's a bit of a twist in the climate, with temperatures ranging from about minus 125 degrees Celsius, minus 195 degrees Fahrenheit, near the poles to a toasty 20 degrees Celsius, 68 degrees Fahrenheit, during the summer months. But hey, we can work with that. Another reason Mars is so appealing is that we've discovered there's water on the planet. Yes, actual water. It's mostly frozen in the polar ice caps and beneath the surface, but this is a game changer. Water is essential for life, and not just for drinking, it's needed for growing food, creating oxygen, and even for fuel. We're talking about the potential to extract water from underground reserves and ice, which could give us the resources we need to survive. This isn't just a science experiment, it's a possible future where settlers could live off the land, literally. But let's be real. Moving to Mars won't be easy. The atmosphere is thin, less than 1% the density of Earth's, so there's very little oxygen to breathe, and the air pressure is much lower than what we're used to. On top of that, there's no protection from the sun's radiation like we have on Earth, and it's incredibly cold. To get around these challenges, we're going to need some serious innovation. The first step will be creating habitats that can keep settlers safe. These habitats will need to be airtight to maintain breathable air, and they'll also need to be insulated against the freezing temperatures. Building these habitats is going to take some serious material science. Think about it. How do you build a home in an environment where the air wants to kill you and the ground is freezing? Well, engineers are already looking at creative solutions. For instance, we might use the very soil of Mars, known as regolith, to build structures. This could be done through a process called 3D printing, where machines build up layers of Martian soil to form protective walls. Or we could rely on inflatable habitats, which are easier to transport but still strong enough to handle the harsh conditions. Once the settlers are safely inside, we need to make sure they have enough food, water, and oxygen. Water, as we mentioned earlier, might be extracted from the planet's frozen ice. Oxygen could be produced through a process called electrolysis, where water is split into hydrogen and oxygen, giving us a steady supply of breathable air. Food production? That's where hydroponic and aeroponic farming systems come into play. These soil-free farming methods will allow settlers to grow crops with minimal resources, perfect for an environment like Mars. Growing plants in Mars' gravity, low light, and cold temperatures will be a challenge, but scientists are working on ways to adapt crops to those conditions. But it's not just about surviving on Mars, we're talking about building a thriving, sustainable colony. The settlers won't just be getting by, they'll need to create a self-sufficient ecosystem. That means growing food, recycling water, and generating energy. And that's where solar power and nuclear energy come in. The thin atmosphere on Mars means solar panels will work just fine, capturing energy from the sun. For more consistent energy, we might also use nuclear reactors to power the colony, especially during the long Martian. Once the basics are in place, it's time to think about the next steps. Expanding the colony. Settlers will need to grow the population, build more habitats, and establish industries. Mining will be key. Mars is rich in resources like iron, nickel, and precious metals, and it's possible to extract these materials and use them to build more infrastructure. In the early stages, settlers will rely on Earth for supplies, but eventually, Mars could become an independent economy, with trade between colonies on Mars, the Moon, and Earth. One interesting part of life on Mars is how the settlers will adapt to their new environment. The lower gravity is going to have some major effects on the human body over time. Studies show that spending extended periods in low gravity can lead to muscle loss, bone density reduction, and changes to the cardiovascular system. But this isn't a deal breaker. Research is already underway to find ways to counteract these effects. Settlers might wear special suits to exercise in, or use advanced medical technologies to prevent muscle and bone degradation. It's all part of the challenge, and the opportunity, of living on Mars. Now, beyond just surviving and thriving, there's also the question of Mars becoming a true home for generations of people. Imagine children born on Mars, who grow up knowing only the red landscape of the planet. Would they ever want to visit Earth? Or would Earth feel like an alien world to them? Over generations, the settlers could develop their own Martian culture, traditions, and ways of life. Mars would no longer be an outpost or a stopover. It would become a new world, a place where humanity could carve out a future that's distinct from Earth. And then there's the big picture. How does Mars fit into humanity's long-term plans? As more and more people settle on Mars, we'll start to see a more permanent human presence in the solar system. Mars will be the first of many colonies, places where people can live, work, and explore. It's not just about surviving Mars, it's about opening the door for humanity to spread out across the stars. Whether it's colonizing moons around Jupiter or Saturn, or even setting our sights on other star systems, Mars will be the first stepping stone in humanity's grand journey into space. Now that we've zoomed in on Mars, let's switch gears and talk about another potential frontier for humanity, the Moon. You might be thinking, wait, didn't we already land on the Moon in 1969? That's true, but today, the Moon is no longer just a place for astronauts to visit and plant flags. It's the key stepping stone for our journey into the stars. If Mars is the ultimate goal for a space colony, then the Moon is going to be our launchpad. a place where we can build the foundations for future space exploration and habitation. First, let's talk about the moon's proximity to Earth. It's only about 240,000 miles away, which makes it much closer than Mars. Roughly 380 times closer, in fact. This makes it a much easier and cheaper destination to get to. Right now, we're already seeing plans for regular lunar missions. NASA's Artemis program, for instance, is aiming to land humans on the moon again within the next few years. But this time, it's not just about landing and leaving. It's about building a sustainable presence there. The moon offers several key advantages, as the first place will establish a permanent human presence in space. For one, its low gravity, about 1/6 of Earth's, means it'll be easier to launch spacecraft from its surface. Imagine using the moon as a launching pad for missions to Mars, the asteroid belt, or beyond. The less gravity, the less fuel needed, and the cheaper and easier it becomes to travel through space. That makes the moon the perfect base of operations for missions to other planets and moons. But there's a catch. The moon doesn't exactly offer a warm welcome. The surface temperature can range from 100 degrees Celsius, or 212 degrees Fahrenheit, in the daytime to minus 150 degrees Celsius, or minus 238 degrees Fahrenheit, at night. The lack of atmosphere means there's no air to breathe, no weather to moderate the temperature, and of course, no protection from radiation. So, to live on the moon, we'll need to create habitats that can shield settlers from these extreme conditions. One of the most promising solutions for living on the moon is building underground habitats. The moon's surface is covered with a layer of rock and dust, which could provide natural protection from radiation and temperature extremes. By digging into the moon's surface, we could create safe, stable habitats without the need to transport massive amounts of building materials from Earth. We could also use lunar regolith, the moon's rocky surface material, to create bricks or concrete to help build these underground structures. This way, we wouldn't need to carry everything we need to survive. We'd be able to use the resources that are already there. Another idea for surviving on the moon is building pressurized habitats on the surface protected by layers of regolith or inflatable structures that can be deployed like tents. These inflatable modules would be much lighter to transport and could be set up quickly to provide temporary shelters while more permanent structures are built. The key here will be building habitats that can withstand radiation temperature fluctuations and the wear and tear of the harsh lunar environment. Water is another major challenge on the moon. While there's no oceans or lakes, scientists have discovered ice in the permanently shadowed craters at the moon's poles. This ice could be harvested and melted to provide water for settlers, and not just for drinking, it could also be split into hydrogen and oxygen to create rocket fuel. That means the moon could one day serve as a refueling station for missions to Mars, the outer planets, or beyond. Imagine astronauts on a mission to Jupiter, stopping off on the moon to refuel their spacecraft for the next leg of. But don't forget food. Since the moon's surface is too barren to grow crops, settlers will need to rely on hydroponic farming or bring pre-grown food with them. Over time, the goal will be to create a sustainable farming system that allows for the growth of plants in controlled environments. And that means getting really creative with growing food in space. With the right technology, the moon could one day be home to thriving greenhouses, where everything from lettuce to tomatoes to beans could be grown for settlers. Now, here's where things get really exciting. The moon also offers incredible opportunities for scientific discovery. We've already started to map out the lunar surface in unprecedented detail, but the moon still holds a treasure trove of mysteries. Scientists believe the moon could hold the key to understanding the history of the solar system. After all, it's been around for billions of years. And because the moon doesn't have an atmosphere, the surface is like a time capsule, preserving ancient evidence of impacts and other events from the early days of the solar system. In addition to that, the moon could serve as a hub for astronomical research. Its lack of atmosphere means that telescopes set up on the moon could get an incredibly clear view of the cosmos without the interference of Earth's atmosphere. Imagine building an observatory on the far side of the moon, where radio signals from Earth don't interfere. Scientists could use this vantage point to study everything from distant galaxies to signals from potential alien civilizations. It could become the best place in the solar system for peering into the unknown. So, while the moon might seem like just a dusty rock floating in space, it's actually a crucial stepping stone for humanity's expansion into the cosmos. The moon is our practice ground, our testing site, our first real experience with living and working in space for extended periods. We'll learn a lot about how to create self-sustaining habitats, extract resources from other worlds, and build the infrastructure we'll need for Mars and beyond. Once we master life on the moon, we'll be ready to expand into the rest of the solar system. The moon will be our proving ground, the place where we test new technologies and techniques that will one day make space colonization a reality. And who knows? Maybe, just maybe, it'll become the first true home away from Earth, a place where humans will live and work for generations to come. Alright, so we've talked a lot about the exciting possibilities of space colonies on Mars and the moon, but here's the thing. Living off-world isn't going to be a walk in the park. In fact, it's going to be one of the biggest challenges humanity has ever faced. When you think about it, space is incredibly unforgiving. There's radiation, microgravity, isolation, and more. So, before we can start dreaming about thriving on other planets, we need to tackle these tough challenges head-on. Let's start with one of the most obvious obstacles, space radiation. On Earth, we're protected from harmful radiation by our atmosphere and magnetic field. In space, though, it's a whole different story. Without that protective shield, astronauts are exposed to cosmic rays and solar radiation, which can cause all kinds of health problems from increased cancer risk to radiation sickness. On the moon and Mars, we can't just rely on Earth's atmosphere to keep us safe. So, scientists are getting creative with how to shield us from that radiation. One idea is using the resources we find on these planets. For example, lunar regolith or Martian soil could be used to create thick protective walls for habitats. By burying habitats under a few meters of soil, we can block out harmful radiation. This is one of the big advantages of living on the moon or Mars. They're not completely devoid of useful materials that can help protect us. Another possibility is using water as a shield. Water is fantastic at absorbing radiation, so if we can create water-based walls or even just keep large tanks of water around our habitats, it could give us the protection we need. This isn't science fiction. It's already being studied by space agencies like NASA and private companies working on space habitats. And let's not forget that water is also necessary for life, so it could kill two birds with one stone. But shielding is only one part of the equation. Let's talk about the impact of low gravity on the human body. When astronauts spend extended periods in space or on a low-gravity environment like the moon or Mars, their muscles and bones weaken because they're not being used as much. On Earth, gravity constantly pulls on our muscles and bones, but in space, they don't have to work as hard. That's why astronauts have to exercise daily to prevent muscle atrophy and bone density loss. On Mars, gravity is about 38% of Earth's, which means it's less of a concern than zero gravity, but it's still not ideal. On the moon, gravity is even weaker, only 16.5% of what we experience on Earth. For long-term settlers, this could result in serious health problems. To combat this, future space settlers will need to rely on regular exercise, but they might also wear special suits designed to stimulate their muscles and bones. Think of it like gravity boots or a wearable resistance system that keeps the body working like it would on Earth. Then there's the psychological toll of living in space. Imagine being stuck on Mars, hundreds of millions of miles away from Earth, with no hope of going home for years. The isolation, the confinement, the constant reliance on technology, this can have a serious impact on mental health. Astronauts have already experienced the psychological strain of space missions, and the further we go into space, the more isolated and disconnected people will feel. Long-term space settlers will need to be prepared for the mental and emotional challenges that come with living off-world. There will be no quick weekend getaways, no running back home to visit family. People will need to be incredibly resilient, not just physically, but mentally as well. Creating a sense of community in space will be crucial. Astronauts and settlers will need to work together, support one another, and find ways to stay connected to Earth. On Mars or the Moon, settlers will have to learn how to live in tight quarters with little privacy. Even the best technology can't replace human interaction, and there's only so much virtual communication can do. Social isolation is a real concern, especially when you're dealing with extreme environments. But there are ways to help with this. Virtual reality could provide a way for settlers to stay connected to family and friends on Earth or even take them on virtual trips back home. Regular communication with Earth and the ability to keep track of time and life back home will help reduce the sense of isolation. And let's not forget about the everyday problems of living in space. Life on the Moon or Mars will be drastically different from what we know on Earth. There are no grocery stores, no restaurants, and no fast food chains to grab a quick meal. Everything we need will have to be grown, manufactured, or shipped from Earth, at least in the early stages. And we'll need to be incredibly efficient with our resources, recycling everything as much as possible. Every drop of water, every scrap of food, every piece of waste will have to be carefully managed. This isn't just about survival, it's about creating a system that works in the long term. Waste management, food production, and water recycling will be essential systems that keep the colony going. As for transportation, it's not as simple as hopping in a car or riding a train. Whether it's getting from one location on the Moon to another, or traveling between Earth, the Moon, and Mars, future settlers will need efficient, reliable transport systems. On the Moon, vehicles will need to be specially designed to navigate the lunar surface's rocky terrain. Mars, with its thin atmosphere, presents its own set of challenges, such as dust storms and extreme temperature shifts. Space vehicles will need to be rugged, reliable, and capable of handling these harsh environments. Then, there's the question of supplies. In the early days, we'll rely on Earth for most of our materials, everything from food to construction materials. But eventually, we'll need to establish systems for producing everything we need right there on the Moon or Mars. This will require advanced manufacturing technologies like 3D printing, which can create anything from tools to building materials using local resources. These technologies are already in the works, and in the future, they could make space settlements a lot more self-sufficient. Alright, so we've got the basics of surviving and living off-world covered habitats, food, water, and shielding from radiation. But now let's talk about something that might not seem as glamorous but is absolutely essential for the long-term success of any space colony sustainability. A space settlement isn't just about building cool habitats and sending humans to Mars or the Moon. It's about creating an economy that can support these colonies for generations, and that's going to require some big thinking, innovation, and a whole lot of resource management. First off, let's talk about energy. A space settlement can't rely on Earth for energy. It would be far too expensive and impractical to constantly send fuel or power from our home planet. So, settlers will need to tap into local energy sources. Luckily, space offers some great options for renewable energy. The Moon, for example, gets a lot of sunlight, which means solar power could be a reliable energy source for lunar colonies. Solar panels could be set up to capture sunlight during the Moon's long days, and we could even store excess energy in batteries for use during the long lunar nights. For Mars, the same principles apply. Solar power will be essential, though it'll be a bit less efficient due to Mars's farther distance from the sun and dust storms that can block sunlight. Still, solar power could provide a major chunk of the energy needed to sustain a Martian colony. What if we could harness energy from nuclear fusion? It's still a technology we're working on back here on Earth, but if we can crack the code, nuclear fusion could provide an almost limitless clean energy source. In space, where resources are limited, we'll need every advantage we can get when it comes to energy production. So, nuclear fusion could be a game changer for space colonies, providing power for everything from life support to manufacturing. Now, beyond energy, the next key component of a sustainable space economy is resource extraction. Imagine you're on the Moon or Mars, and you're running low on materials like metals, water, or building supplies. How do you keep the colony going without sending expensive shipments from Earth? The answer lies in mining. On the Moon, lunar regolith, the dust and rocks covering the surface, could be mined for useful materials like oxygen, silicon, and metals such as iron and aluminum. Regolith could even be used as a building material, as we discussed earlier. This idea is known as in situ resource utilization, ISRU, and it's a game changer. Instead of having to rely on Earth for everything, settlers could use the materials already available on the Moon or Mars to build and maintain their colony. They could also extract water from ice found at the lunar poles or from underground aquifers on Mars, which would be essential for everything from drinking water to growing food. For Mars, mining becomes a little more complicated but still very possible. Mars has abundant resources, including iron, nickel, and precious metals. Mining on Mars could be key for creating the materials needed for habitat construction, fuel production, and even to trade with other space settlements. The goal would be to create a self-sustaining economy where materials are sourced locally, minimizing the need for shipments from Earth. One exciting potential resource is a material called helium-3. This is an isotope of helium that is incredibly rare on Earth, but abundant on the Moon. Helium-3 could be used in nuclear fusion reactors to create nearly limitless energy. If we can figure out how to mine and use helium-3, it could completely change the energy game both on Earth and in space. But of course this is a long-term vision, and we're still working on the technology to make it happen. Let's also not forget about manufacturing. In space, everything we need will have to be built or repurposed. That means we'll need advanced manufacturing techniques like three-dimensional printing and robotics. Imagine being able to print tools, spare parts, or even entire buildings right on the Moon or Mars using local materials. Three-dimensional printers could be a lifeline for space settlements, especially in the early stages when shipping supplies from Earth isn't practical. In fact, three-dimensional printing could even be used to grow food. Scientists are already experimenting with three-dimensional food printing, where ingredients like powdered vegetables, proteins, and fats are turned into actual meals. For settlers on Mars or the Moon, this could be a game changer. Instead of relying on pre-packaged food, settlers could print out fresh meals on demand, tailored to their nutritional needs. And then, there's the idea of space-based industries. As space settlements grow and become more self-sufficient, they'll need to develop their own industries. Whether it's mining, manufacturing, or research, space colonies will create their own local economies. These industries will likely specialize in the production of goods and services needed for space living, such as life support systems, renewable energy tech, and building materials. And as the space economy grows, it could create new markets, everything from tourism to space farming to asteroid mining. Let's talk about that for a second. Asteroid mining. It might sound like science fiction, but it's actually a potential gold mine, pun intended. Some asteroids are packed with valuable metals like gold, platinum, and rare earth elements, which are used in everything from electronics to clean energy tech. If we can develop the technology to mine asteroids, we could create an entirely new supply chain for valuable resources. This could also be a major source of wealth for spacefaring nations and private companies. It could be the start of a new space economy where materials are traded between Earth, the Moon, Mars, and beyond. This space economy, as ambitious as it sounds, is already starting to take shape. Private companies like SpaceX, Blue Origin, and others are already working on technologies that could one day make space settlements a reality. Governments around the world are investing in space exploration, not just for scientific reasons, but because they see the potential for economic growth in space. As space settlements grow, we'll see more innovation in space technology, from propulsion systems to sustainable life support. These innovations won't just stay in space, they'll trickle down to Earth too. Many of the technologies developed for space colonization could have huge benefits back home, from better energy solutions to new manufacturing techniques and even advancements in medicine. Now let's talk about something that's going to be absolutely crucial for the success of any space colony technology. And when I say technology, I'm not just talking about the usual stuff like spaceships and habitats. I'm talking about cutting-edge tech like artificial intelligence and robotics. These technologies aren't just nice-to-haves. They're going to be essential to making space settlements a reality. In fact, without artificial intelligence and robotics, it would be nearly impossible to build and maintain colonies on the Moon, Mars, or anywhere else in space. First, let's talk about artificial intelligence. We're already seeing AI being used on Earth in a variety of ways, everything from self-driving cars to healthcare diagnostics to smart homes. But in space, AI could be even more important. Space is harsh, remote, and full of challenges. To make a space colony work, we'll need AI systems to help manage everything from life support systems to resource extraction to even day-to-day operations. For example, life support is one of the most critical systems for any space settlement. If something goes wrong, say, if the oxygen levels drop too low or the temperature fluctuates beyond safe limits, it could be catastrophic. AI could be used to monitor all these systems in real time, identify potential issues before they become emergencies, and even automatically make adjustments to keep the colony safe. Think of AI as the colony's unseen protector, always watching over the critical systems that keep people alive. But it doesn't stop there. AI could also help with the management of resources like food, water, and energy. By analyzing data from sensors and systems, AI could help optimize the use of these resources, ensuring that settlers don't waste anything. AI could predict when a resource might run low and alert the settlers so they can act in time. It could also help streamline agricultural systems, from hydroponic farms to three-dimensional food printers, to make sure they're running at maximum efficiency. Essentially, AI could be the brain of the colony, keeping everything in balance and making sure that the colony's survival isn't left to chance. Then there's robotics. If you've seen a robot working on Earth, you know they're pretty good at tasks that are either too dangerous or too repetitive for humans. Well, imagine how useful robots will be in space. They'll be the hands and eyes that help build infrastructure, repair equipment, and even assist with scientific research, all while minimizing the risks to human settlers. Robots could be used to explore the surface of planets and moons, conducting research, collecting samples, and mapping the terrain. On Mars, for example, rovers could gather data on the soil and atmosphere, helping scientists determine the best places to build colonies. In fact, we're already seeing robots like NASA's Perseverance rover do this, so you can imagine how advanced they'll be by 2100. But robots won't just be limited to exploration, they'll also play a huge role in construction. Building on the Moon or Mars isn't going to be easy. The environments are harsh, and it's going to be dangerous for humans to do much of the heavy lifting. Enter the robots. Automated machines could mine resources, construct habitats, and even assemble solar arrays or communication towers. The best part? Robots can work around the clock without needing sleep or rest, which will be crucial for building the colony in a reasonable time frame. One idea that's being explored is robotic 3D printing. Robots could print entire buildings or structures using local materials like lunar regolith or Martian dust. These construction robots could take the place of human laborers and build everything from simple shelters to massive industrial complexes. The technology is already advancing rapidly, and by the time we get to 2100, we could have fully automated construction teams working on the surface of the Moon or Mars with minimal human involvement. But there's also going to be a need for robots to assist with everyday tasks. Think about it. On a space station or colony, humans will need help with everything from routine maintenance to cleaning to moving heavy objects. Robots could take care of a lot of these tasks, freeing up settlers to focus on more complex and creative work. And with the right design, these robots could be autonomous, meaning they wouldn't need constant human supervision. AI and robotics will also be crucial for medical care. In space, getting sick or injured is a huge concern. Medical supplies and expertise will be limited, so having robots and AI systems that can diagnose and treat common issues will be critical. Imagine a robot that can perform basic surgeries, or a diagnostic AI that can assess a person's health and recommend treatments based on real-time data. These technologies could save lives and prevent small issues from turning into big problems. Now let's take a step back and think about the big picture. AI and robots aren't just tools. They'll actually play a role in the development of space culture. These technologies will be integral to the way space settlers live and work, shaping the daily lives of everyone on the colony. Over time, settlers will likely form relationships with AI systems and robots. In fact, some researchers believe that as AI gets more advanced, it might become an integral part of the social fabric of space colonies. People could have virtual assistants that help them with everything from organizing their schedules to providing emotional support. And when you think about the long-term future, AI and robots could help humanity extend its reach beyond Mars and the Moon. As we look to colonize distant moons or even exoplanets, AI and robotics will be the key to exploring and settling these far-off worlds. They'll be the first pioneers, sent ahead to survey, gather data, and build the infrastructure necessary for human settlement. In a way, AI and robotics will be the unsung heroes of space colonization. While humans will be the ones to live, work, and thrive in space, these technologies will make it all possible. They'll support us, protect us, and help us do things we could never do on our own. Without AI and robotics, the dream of space colonization would remain just that, a dream. But with them, the frontier of space becomes a reality. As we move forward into the future, we need to think big. Space colonization isn't just about planting flags on other planets, it's about transforming humanity's place in the universe. When we look at the possibilities for life on the Moon, Mars, and beyond, we're not just talking about survival, we're talking about expansion. This is the beginning of a new chapter for us as a species, where Earth isn't the only home we know. The next few decades will be crucial. As technology advances and we solve problems like energy production, resource extraction, and sustainable living, humanity's ability to thrive beyond Earth will become more realistic. The goal is not to just have tiny outposts on the Moon or Mars, but to build fully fledged, self-sustaining colonies where generations of people can live, work, and raise families. And as those colonies grow, they'll evolve into something more, becoming hubs for scientific research, industry, and even culture. Think about it. What does a space colony look like in 2100? By that point, we'll have well-established infrastructure, advanced AI systems keeping everything running, and robots assisting with all the manual labor. These colonies will likely be small at first, maybe housing a few hundred or thousand settlers, but as the population grows, so will the technology and resources. We could see entire cities built in domes or underground habitats on Mars or the Moon, complete with artificial ecosystems, greenhouses, and renewable energy systems. But even beyond those initial colonies, we'll start to think about other planets, moons, and even asteroids. The solar system will become humanity's new playground, with missions and settlements stretching all the way out to the outer planets. The idea of traveling to and living on places like Europa, one of Jupiter's moons, or Titan, Saturn's largest moon, will no longer be science fiction. These moons are believed to have subsurface oceans, and we could one day harvest those resources or even use them as bases for further exploration. With advancements in space travel, getting from one planet to another will become faster and more efficient. Imagine a future where you could hop on a spacecraft, and instead of spending months or years traveling to another planet, you could get there in a fraction of the time. Spacecraft powered by advanced propulsion systems like nuclear fusion or antimatter might make these long-distance trips a reality. And when we think about the future of space tourism, it's not just about going to the Moon for a week-long vacation. People might be traveling to colonies on Mars, or even to stations floating in space for a completely new type of holiday. But the future of space colonization isn't just about expanding humanity, it's about redefining what it means to be human. Living in space will force us to rethink everything we know about society, culture, and human interaction. Imagine living on Mars, where the gravity is lower, the days are longer, and the environment is radically different from Earth's. How will our bodies adapt to these changes over generations? What kind of new social systems and structures will emerge in space colonies? How will the isolation and small communities affect our behavior and relationships? Over time, space settlements could become incredibly diverse, with people from all walks of life coming together to create something entirely new. These communities might be a mix of scientists, engineers, artists, and dreamers, all working together toward common goals. Space could become a place where cultures mix and new ideas take root, where the limitations of Earth's past fade into the background and humans begin to truly flourish in the cosmos. And let's not forget about the ethics of space colonization. As we venture out into the stars, we'll need to consider not just the technological and logistical challenges, but the moral implications of our actions. What about the possibility of contaminating other worlds with Earth-based life? How do we ensure that space exploration benefits all of humanity, rather than just a select few? These questions will become more urgent as we start to establish permanent colonies in space. We'll need to think carefully about our role as stewards of the universe and what kind of legacy we want to leave behind. There's also the bigger question of whether humanity is ready for this kind of future. Colonizing space will require a massive shift in how we think about resources, cooperation, and survival. We won't be able to rely on old systems or established ways of doing things. Instead, we'll have to innovate, adapt, and work together across borders and cultures to make this future a reality. The stakes are high, but the rewards could be unimaginable. A thriving, spacefaring civilization might hold the key to solving problems like climate change, resource scarcity, and overpopulation here on Earth. And when we look beyond our solar system to distant stars and exoplanets, the possibilities become even more mind-blowing. If we master interstellar travel, it opens up the possibility of colonizing other star systems. We could find planets that are Earth-like, maybe even habitable, and begin to expand our reach even further across the galaxy. With the technology we're developing now, interstellar travel may be closer than we think, something that could shape the future of humanity in ways we can't even fully predict. So, what does all of this mean for us right now? It means we're on the cusp of something extraordinary. The seeds of space colonization are being planted today, through space agencies, private companies, and the visionaries pushing the boundaries of what's possible. We're laying the groundwork for a future where humanity isn't confined to Earth but is free to explore, settle, and thrive throughout the cosmos. The dream of space colonization is becoming a reality, and the future of humanity is no longer just on this planet, it's out there in the stars.